Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Oumuamua, the interstellar object Harvard's top astronomer says is not natural. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In October 2017, astronomers detected the first known interstellar object passing through our solar system. Its shape was unlike anything seen before, elongated like a cigar, an estimated 400 meters long, tumbling end over end as it flew. Its reddish color suggested surface chemistry from deep interstellar space. Then, as it left the solar system, it began to accelerate, gaining speed beyond what the combined gravitational effects of the sun and planets could explain, with no visible comet tail providing thrust. Harvard astronomer Avi Loeb, chair of the Harvard Astronomy Department, published a paper arguing that the most parsimonious explanation for the acceleration, given the absence of outgassing and the object's extraordinary shape, was that it was a thin light sail pushed by solar radiation pressure. A light sail of the dimensions required to produce the observed acceleration would have to be a fraction of a millimeter thick. No natural process produces objects that thin at that scale. What flew through our solar system 6 years ago, and where did it come from? This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The scale of the universe is so far beyond ordinary intuition that even physicists struggle to hold it in mind. The observable universe contains an estimated 2 trillion galaxies, each containing hundreds of billions of stars. The Milky Way alone has between 100 and 400 billion stars. Conservative estimates suggest that 1 in 5 of those stars has a planet in the habitable zone, the orbital range at which liquid water can exist on the surface. That gives our galaxy alone somewhere between 20 and 80 billion potentially habitable worlds. Against those numbers, the claim that Earth is the only planet to have produced intelligent life seems extraordinary. The statistical argument for extraterrestrial life is almost overwhelming. And yet we have no confirmed contact, no artifact, no verifiable signal. The contrast between the mathematical expectation of abundant life and the apparent emptiness of the cosmos is the Fermi paradox, and it is one of the deepest unsolved problems in science. The paradox has generated dozens of proposed solutions. From the Great Filter hypothesis, some catastrophic barrier prevents civilizations from becoming spacefaring, to the zoo hypothesis, they are watching us, but not yet making contact. To the simulation argument, the universe we observe is itself an artifact. None of these has been confirmed. All of them have troubling implications. The Fermi paradox is not a curiosity. It may be the most important question the human species has ever faced. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding Oumuamua, the interstellar object Harvard's top astronomer says is not natural, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Oumuamua was discovered on October 19, 2017, by astronomer Robert Woerich using the Pan-STARRS telescope at Hailakala Observatory, Hawaii, approximately 40 days after it had passed its closest point to the Sun. Its Hawaiian name means scout or first distant messenger. It was moving too fast to be gravitationally bound to the solar system, confirming its interstellar origin, the first such object ever confirmed. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Oumuamua's estimated dimensions were approximately 400 meters long by 40 meters wide, an aspect ratio of 10:1, far more elongated than any known solar system asteroid or comet. It was tumbling end over end with a rotation period of approximately 3 hours. Its reddish surface color was consistent with space weathering by cosmic ray exposure over long interstellar travel. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. As Oumuamua moved away from the Sun, it exhibited non-gravitational acceleration. It was speeding up at a rate that could not be accounted for by the gravitational influence of the Sun or any planet. This type of acceleration is seen in comets, where outgassing of volatile material acts as a rocket. No comet tail, no gas emissions, and no dust were detected from Oumuamua by any telescope. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Avi Loeb and Shmuel Beerley published a paper in the Astrophysical Journal Letters in November 2018, proposing that Oumuamua could be a light sail, a thin, flat sheet of material prop, held by radiation pressure from the Sun. Their calculations showed that a sail approximately 0.3 to 0.9 millimeters thick, with a surface area consistent with the observed reflectivity, would produce exactly the measured acceleration. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of astronomer Darrell Seligman and colleagues published an alternative in 2020, proposing that Oumuamua was a fragment of nitrogen ice, similar to the surface composition of Pluto, that had been ejected from an exopluto by a planetary collision or stellar perturbation. Nitrogen ice sublimating in sunlight would produce outgassing invisible to telescopes while providing the observed thrust. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. The SETI Institute aimed radio telescopes at Oumuamua using the Allen telescope array shortly after discovery. ND detected no artificial radio signals. By the time advanced observational campaigns were organized, the object was already too distant for detailed characterization. It is now far beyond the orbit of Neptune and entirely beyond the reach of any current or planned telescope. Taken together, These facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Oumuamua, the interstellar object Harvard's top astronomer says is not natural. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Avi Loeb's light sail hypothesis holds that Oumuamua is a piece of alien technology, either an active probe, a defunct solar sail from a dead civilization, or debris from a technological structure whose thin geometry and radiation pressure acceleration can only be explained by artificial construction. Loeb argues that scientists dismiss this explanation prematurely due to a cultural bias against considering extraterrestrial technology as a hypothesis. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that Seligman's nitrogen iceberg hypothesis proposes that Oumuamua was a fragment of solid nitrogen from the outer surface of an exopluto, a Pluto-analog planet in another star system, disrupted by collision and ejected into interstellar space. Sublimating nitrogen would be invisible to telescopes while providing enough thrust to explain the acceleration. The hypothesis requires a specific type of exoplanet disruption that has not been observed but is theoretically plausible. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that a standard comet with unusual composition, potentially high in molecular hydrogen ice or other exotic volatiles, could produce outgassing invisible to current instruments while generating the observed non-gravitational acceleration. The absence of a detected coma or tail is a challenge for any outgassing model, but does not definitively rule one out given the limitations of observations made when the object was already receding. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Oumuamua, the interstellar object Harvard's top astronomer says is not natural, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence, as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the non-gravitational acceleration was confirmed independently by multiple teams analyzing Oumuamua's trajectory data. The magnitude and direction of the excess acceleration, proportional to 1/R2 from the Sun, exactly as radiation pressure would predict, was consistent across all analyses and could not be attributed to gravitational perturbation by any known body. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented no outgassing signature was detected by any telescope during the observation window. Comets of comparable size produce readily detectable gas and dust emission when heated by the Sun. The complete absence of any detected coma, tail, or molecular emission from Oumuamua placed stringent upper limits on outgassing rates that are difficult to reconcile with standard comet models. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the second confirmed interstellar object, Borisov, was discovered in 2019 and was definitively cometary. It showed a clear coma and standard cometary behavior. Borisov was unremarkable in every way. Oumuamua, by contrast, showed none of Borisov's comet characteristics despite arriving from the same interstellar environment, suggesting the two objects were fundamentally different in composition. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Oumuamua, the interstellar object Harvard's top astronomer says is not natural. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Avi Loeb published Extraterrestrial in 2021, making his full case for the artificial hypothesis and founding the Galileo Project at Harvard to search systematically for similar objects. The Galileo Project has deployed dedicated sky survey instruments and is actively searching for interstellar objects. Seligman's nitrogen ice model is currently favored by most astronomers as the most plausible natural explanation. Oumuamua is now unreachable by any current technology and will remain so. A future interstellar probe, proposed but not funded, would need decades of travel time to catch it. The debate between Loeb and the mainstream continues actively in the literature, and the question of what exactly flew through our solar system in 2017 will likely remain open indefinitely. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Oumuamua, the interstellar object Harvard's top astronomer says is not natural, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Oumuamua ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.